In this chapter, we're going to be looking at some essential JavaScript statements, statements that are essential to every language, conditional expressions, basic control statements, and arrays. We're going to start out looking at conditional expressions, and the two things we're going to be looking at are relational operators and logical operators in this video. Let's talk about relational operators. In the previous chapter, we looked at arithmetic operators, and those are things that we're very familiar with. Arithmetic operators do things like adding two numbers together or subtracting two numbers. A relational operator is an operator that does a test between two values. And relational operators always return a true or false value. And we often call that a Boolean value, named after the great mathematician Boole. So here are 6 relational operators that we'll be using in JavaScript. The first one is the equal to operator. Now remember, a single equal sign is the assignment operator. If we see a single equal sign, it takes whatever expression is on the right side and assigns it to the variable or item on the left side. Could be a constant, could be a variable. So we can't use the equal sign to do a test to see if two things are equal, because the equal sign is already being used as the assignment operator. So we use a double equal sign. If you see a double equal sign, that means we're testing to see if something on the left is equal to something on the right. And if it is, that expression is true. If it is not equal, if we do this test and the two things aren't equal, it will be evaluated as false. Okay. So we can evaluate to see if two things are equal, or we can use this expression, which is exclamation point followed by equals, to evaluate to see if two things are not equal to each other. We can also evaluate two things to see if the item on the left is greater than the item on the right. That's the greater than symbol, which you're probably familiar with from elementary algebra. We can also check to see if two things if one thing is less than the other. And we can do some checks to see if something is greater than or equal to an item, or less than or equal to. So those are our relational operators, and whatever's on the left and right will get compared depending on what we're checking. They will always give us a result of true or false. They will give us a Boolean answer. So let's show some examples here. Right here, we're using a double equal sign. So we're looking to see if this could be a constant. It's some kind of identifier. It could be a constant, could be a variable. And we're looking to see if that constant is equal to the word Hopper, or the name Hopper. But we're looking to see if last name holds the same string Hopper. The last name is equal to Hopper. This will evaluate as true. If it is not, it will evaluate as false. Here's another one using double equals to compare an integer literal on the right, the number 10, and an identifier called test score on the left. If the test score is equal to 10, then this will evaluate true. So here's using not equals. We're going to look at the first name and see if it's not equal to Grace. So if the first name is not Grace, this expression will evaluate true. First name is not equal to Grace. So I like to kind of read them that way, especially when you put the nots in there, because that can confuse you a little bit. And I would say the first name is not equal to Grace, true or false. And if the first name is not equal to Grace, then that statement would be true. The number of months is not equal to 0, true or false. Here we're using the greater than sign to compare a test score to the value 100. If the test score is greater than 100, this would evaluate as true. If it is equal to 100, it would be false. If it is less than 100, it would be false. Same thing for our age here. We're comparing our age to see if it's less than 18. If it's equal to 18, it would be false. If it's greater than 18, it would be false. And now we have some comparisons with equals. Let's compare our distance to see if it's greater than or equal to the limit. So in all these other ones that we've done so far, we've used a literal value on one side. And this one, where it looks like we're using two different identifiers. Compare the distance variable to the limit variable. If the distance is greater than or equal to the limit, it's going to return true. Here's one we're checking to see if the stock is less than the value we need to reorder the stock. So is the stock less than the reorder point? Less than or equal to the reorder point. And then on this one, we have an expression on the left side and a number on the right, which the number is an expression too. It's just an easy one. It's 0.1. When we do the comparisons, the expression on the left gets evaluated before we compare the things on the right. So we're not comparing 100 to see if it's greater than or equal to 0.1. We're taking the rate, dividing it by 100. We evaluate the expression on the left first. We can evaluate the expression on the right first, which doesn't need much evaluation in this case. And then the result of the expression on the left is compared to the expression on the right. So is the rate divided by 100 greater than 0.1? That's what we're checking. We also have a test that we can do called is NaN. Is it not a number? So in these we were checking relations of greater than, equal to, less than. Here's another expression that returns a Boolean value, and we know it because of the way this function is named, is. Anytime you see the word is in front of a function, you can be pretty sure that it's returning a Boolean. It's going to give us back a true or a false value. And then this particular one, is NaN, checks to see if something is a number. So it's going to look at an expression, see if the results inside it are a number or not. If it's not a number, it will be true. Hopper is a string. That is not a number. So is NaN on Hopper says true. It returns a true value. Okay. 123.45 is a number. Okay. It is a number, so this returns false, because this tests to see if it's not a number. Is this not a number? False. It is not. So that one can also get a little bit confusing when you're looking for that false condition, because of the word not is in here. It kind of reverses the logic a little bit. If it's not a number, return false. If it's not a number, return true. If it is a number, it returns false. I'm going to stop there, and in the next video we're going to talk about the logical operators, which lets us connect some of these conditional operators so we can compare multiple things. So we'll look at that in the next video.